of our experts at Softing. He's based up in Newburyport, Massachusetts, near Boston. So yeah, if you would like to learn more about these products or get more specific, please get in touch with Wayne, and he can get in touch with us, and we can either do follow-up webinars or sales calls with you.
First of all, can you see my screen? I'm sharing my title screen right now, OPC UA Indirect Database Data Exchange. Can you see that?
Yep, we got it, Alex. We got it.
Okay, okay. Let's see, okay. So I'm Alex, last name Tabora, T-A-B-O-R-A. I'm an applications engineer for Softing, and I've been with the company for about 4 years now. I provide application support for most of our end user products, and so I'm going to be covering these topics today. I'm going to be talking about data exchange methods for ControlLogix, and we will review data exchange between ControlLogix and a database, and also data exchange between ControlLogix and an OPC UA client. And well, Scott already mentioned a few things about Softing. I have a few slides that I can show you to show you about our products and actually our product range. Okay, let's get started. So if you need to transfer data between ControlLogix and a database or an OPC client, basically you're faced with two options. You can come up with a PC-based solution, and for this you would need a computer and develop code or use an off-the-shelf application. And if you're developing code, not only you need PLC expertise, but also database or OPC knowledge, depending on which way you're going. Another option is to use a hardware solution, like a Softing eATM module. And eATM stands for Enterprise Appliance Transaction Module. And the term appliance is used because these modules are meant to perform a relatively narrow set of tasks once you configure them, and they work independently. So you need some basic PLC knowledge, but no database or OPC expertise is necessary. And you'll see how really basic the knowledge on the PLC side is. So how do you choose? There are a few things that you need to consider, starting from the architecture. Do you want a standalone hardware solution, or do you prefer to run software on a computer? Now, besides ControlLogix, do you need to support a different platform or other PLC brands? How many PLCs do you need to connect to? And how many databases or OPC clients do you need to support? Is it important to have the capability to log the transactions locally or buffer the data in case the connection to the database is lost, for example? Do you need failover in case the connection to the primary data destination is lost? You also need to consider the cost and your budget. Who will own the solution? Is it IT, or is it the controls people, or will you share the cost? And after the solution is implemented, will there be funds available for future support, maintenance and updates, and how easily can you get those funds? On the security side, how will your system security be affected by adding a PC-based solution or a dedicated hardware solution? If it's a PC-based solution, are you required to keep the operating system and software up to date? If so, how will that affect your data transfers? How will protected your solution will be against viruses and malware? Do you need to protect access to the data or the system configuration? And what kind of data security do you need? You need certificates, encryption, for example. Support and maintenance. Who will set up the solution and who will maintain it? How often will the configuration need to be changed? How well does IT work together with the plant floor? So it all boils down to how accessible is your support when needed. So you can take all that into consideration, and so let me tell you why you would use an eATM module, a hardware solution. First, they are physically integrated in a ControlLogix chassis. This makes them plant floor maintainable, and they also have the same industrialized packaging as any other ControlLogix module. Second, they are dedicated hardware solution. So you don't need to modify the PLC code or even know what the code is. There's also no need to develop code as the data exchange is configured right in the via straightforward GUI right in the module. And once it's configured, the module manages the data exchange. And third, it's secure. You don't have to deal with operating system upgrades, patches, or viruses. Also, there's no way to modify the configuration other than through its user interface, which requires you to enter a username and password. We have two modules that fall under the eATM family. We have the tManager and the OPC UA server. They both look the same. They just look like a regular ControlLogix module. And here's a high-level view of the data transfer that contrasts tManager to the OPC UA server. So tManager does end-to-end data handling and is intended as a means of moving data to and from databases. It's bidirectional. And while the OPC UA server module is intended to turn a ControlLogix into an OPC UA server. It's also bidirectional, but one is a server for OPC UA clients, and one is a transaction manager between PLCs and databases. So a little more on the applications for each one. So tManager's systems are typically used in manufacturing processes. For example, database inserts of production data or execution of stored procedures for recipe downloads. Now, on the other hand, the applications for OPC UA systems are typically SCADA-like. So it's a client-server architecture in which you have a client that can subscribe to tags and read and or write to them. Although the OPC Foundation is currently working on real-time data, currently typical data transfer speeds are 1 second or slower than that. Okay, now I'm going to talk a little bit more in depth about the tManager module. So here we can see the connectivity adapters on the left side that are available for, and on the right side. On the left side we have the computer adapters. So the databases it supports are Microsoft SQL, Oracle, MySQL, Excel tables, Access, and DB2. JMS messaging is also supported. And lastly, data can also be sent as files via TCP or UDP, FTP, or via email. Now on the right side, we have the controller adapters, and you can connect up to 16 controllers total via the backplane. You can, if you have a communications bridge, you can go through those and get have access to the tags. Or also you can enable, it has 2 Ethernet ports. You can enable those ports to access other devices like ControlLogix or ControlLogix via Ethernet FP, and also have access to those tags. The tManager is very easy to configure. So the first thing you need to do is you establish a connection to a database. So you need to enter the IP address of the host computer. You need to enter the database name and your credentials, username and password. So after you do that, the tManager will connect to the database and it will enumerate all the tables available for you. tables, stored procedures, all that. And also, you'll be able to, the PLC tags are automatically enumerated for you. So you don't need to type in anything. So after you establish a connection to the database and you see the PLC tags, you can go ahead and configure a map. And here's where you link PLC tags to database columns. So you just drag a tag, for example, to the PLC, and then you add a column from one of your tables, and you drag it to the map, and then you make the connection. You can do it manually, or there's a button here that you can click, and if you have them lined up properly, all the tags will be linked to the respective database columns. So once you create the map, you're going to need a trigger to trigger the transaction, and it can be periodic, it can be a scheduled event, it could be triggered by the PLC, or it can be a combination of conditions. You also need to configure an endpoint, and an endpoint is where you can enable features like store and forward. I'll talk a little bit more about that in a few slides. You can configure failover to a secondary database, and you can set up alerts in case of transaction error. Once you have the map, the trigger, and the endpoint, you just drag them to a message path. So you add the trigger, you add your map, and you add your endpoint, you hit OK, and then you have your transaction ready. So everything is done via drag and drop, and it's very, very easy to visualize how everything is configured. Now, some people think about tManager as a historian, and it's actually not a historian. The tManager was designed to handle transactional data. So in transactional or relational data, transactions can go both ways. So you can do a recipe download or just upload process data onto a database. And it's ideal for storing contextual data about processes. Now, historian, on the other hand, is designed for data collection. And the information is typically simple process data that you record at a very fast speed. So the tManager is a transaction manager, not a historian. Common applications for a tManager are download of instructions or recipes from a database to a PLC, or production data inserts onto a database, like I already mentioned. An example of an instructions download would be something like this, where you have a barcode scanner and that reads a pallet ID. And since every time you read a new pallet ID, you're going to have a change in that value, you can use that value that can be your trigger. So that trigger will start the transaction in which a store procedure in a database will take that value, that pallet ID, and we'll look it up in the database, and we'll look up the recipe for that ID, and you will get the recipe for what to load on the pallet. So the recipe values will be mapped to the controller, and the controller tells the palletizer what to load. And a database insert, very simple. So you need a trigger to activate the data transfer. It can be a PLC value, an event, which could be time event or a PLC condition, or a combination of both. And once the trigger is active, the data is collected from the control system and inserted into the database. And the database acknowledges receiving the data, and the transaction is then completed. Now, here are some benefits of using a tManager. First, faster implementation. You don't have to type in tag or column names. They are all automatically found and listed for you. easy configuration via a simple graphical user interface. There's something called functoids, which are blocks that you can place between a PLC. So when you're making a map, you can place a functoid between a PLC tag and a database column. So you can do things like math operations, data conversions, etc. So you can manipulate the data before it gets to the database. Also, Windows functions like copy and paste and search and replace are available if you need changes. If you have a big project that you need to make, let's say, a tag name change, so you need to go into your tManager project and change that tag name, you can do a search and replace and do the change really fast. Also, entire user-defined data types can be mapped to a database XML column as one item, and that way you optimize communications. Another group of benefits pertains to robust data handling and auditing. Once configured, the module independently handles all the data transfer. Even though you don't have to know anything about SQL statements, once you create a transaction, you can share the resulting SQL statement with the database administrator. When you create the message path, there's a button that is called SQL statement. You click on that button and you see exactly what the SQL command is, and you can share that with the database administrator to confirm that you're doing the right operation. Also, you have data buffering and destination failover. Data buffering is also called store and forward. And if communication to the database is lost, data can be stored on the tManager. And then it is pushed to the database once communications is restored. You can also set up destination failover if you have an alternate or secondary database in case you lose connection to the primary database. Also, you have logs and notifications. You can log all system events are logged by default for troubleshooting, but also user changes can be logged to monitor who made changes and what was changed. Also, the transactions can be logged for troubleshooting purposes. And to be informed of any errors, you can set up email alerts. So here's a little bit more about the store and forward functions. When you enable it, this feature places transactions in a queue on the tManager until the destination is available. So you choose how much memory in the tManager you want to make available for specific transaction, and once it gets full, you can select the override policy. Do you want to discard the oldest message or the newest data? With time to live, you can set an expiration period for messages in the queue. Maybe you have the store and forward enabled and it got full, but you're not going to need it the next day. So you can select here to when to flush all the data in the queue. And lastly, you can get email alerts when the endpoint goes into store and forward mode, and you will get additional emails when the queue is all at 50%, 80%, and 100% full. And by the way, you get 2 gigabytes of memory on the tManager, and you can distribute those 2 gigabytes within all your transactions, and you can assign up to 250 megabytes for each transaction for store and forward. This is the other feature, the failover feature is enabled. Messages are sent to a secondary destination when the connection to the primary destination is lost. So here you can configure how many connection retries before you switch to the secondary database. And also, how often should the tManager check for a connection to the primary destination, so to switch back to normal operation. Another group of benefits are related to security and traceability. The tManager has no open operating system, so it's virus resistant. It can only be accessed through the tManager user interface and only through its Ethernet ports. And the user interface, as I mentioned before, it requires a username and password. And also you can set up privileges for different users. Maybe you can want to set up a user that can only view projects or start and stop a project, and others that have full access. So there's a lot of options. Like I said, it has 2 Ethernet ports, and they are electrically isolated. So you can access the automation network from the office network and vice versa. You also have the audit log, which will record any users that have logged onto the appliance and with a timestamp, and it will log what type of changes they made. And the last group of benefits that I'd like to mention is the straightforward maintenance. You have a very flexible and easy to implement spare part options. You can buy a fully licensed module, spare module, or you can buy a module without a license, and you can request a license transfer, or you can just buy the memory card as well. The configuration is stored in a single backup file, so it's very easy to keep a backup of all your configuration and then transfer that to another module. The software that comes with the tManager, doesn't require a license, so you can install it in multiple PCs. You also get extensive help. It's a context-sensitive help throughout the whole user interface. And also we have a very complete knowledge base on our website. And you can also place service requests through our website or by phone. We have support charges via phone or email. And we also can provide support via WebEx meetings. Okay, so now I want to show you some real-life applications. This was a project by PCC Airfoils for a turbine blade heat treatment application. And here, the challenge was to upgrade a Microsoft SQL-based system that handled recipe downloads and production data uploads. And it included a mix of PLC families. And the goal here was to replace the Visual Basic scripting implementation with something faster and more robust. So the solution, a new ControlLogix PLC with ENBT module and a tManager was added. And so this provided fast access to all the existing PLCs and a way to concentrate all the data for monitoring. And now the tManager replaced the Visual Basic script to handle the data exchange. So as a result, they got much faster data exchange rates. It went from about 20 seconds using the scripts down to under 100 milliseconds. Increased manufacturing throughput by 16%. Configuration time was reduced by 75%. And investment was paid back in just a few days. And this is all later provided by PCC. And you can find all these documents on our website. And there's much more there that you can find. This second application was a project at NEMAC. They make aluminum components for.
They make aluminum components for the next example. I think there was a question from a few minutes ago that perhaps didn't get answered. I just saw was about a limit. What was the limit to the data buffering size?
It was 250 megabytes. Hello?
You hear me? Yep, thanks. I think that answered the question.
Okay. Okay, this second application was a project at MEMAC, like you said. So this application consisted of a mix of data collection and bidirectional data transactions. And so at the beginning of the process, each part gets a birth certificate, and along the rest of the process, production information is stored at each step in real time into the part's genealogy log. So in addition with the equipment being used. So information on the equipment for production parameters and cycle time was also collected and made available via web application. So here the challenge was to implement that track and trace process, and 5 isolated production lines had to be integrated. They had a mix of legacy controllers. They were using Visual Basic scripting in some areas, and they wanted the ability to buffer data in case of loss of communications. So the solution, they added 3 ControlLogix systems as data concentrators to integrate all the data from all the different lines. They used tManagers to take care of the data exchange between the PLCs and the database. And as a result, they got a much faster data exchange, even faster than what they expected. They now have the ability to have another tManager module available for a quick disaster recovery, and they can reuse that at multiple locations. And the customer was very confident in the validity of the transactions due to the handshaking and error messaging from the tManager. Okay, now let's talk about OPC UA and the Softing OPC UA server module. So I'm going to start with talking about what OPC is. Some of you might be familiar with it, but I see that especially OPC UA is a leading technology in Europe. It's actually the preferred technology to move into Industry 4.0, but here in the US is taking a little time to catch up, but I can see every year that its implementation is increasing. So let me start with defining OPC for those who are not familiar with it. So OPC stands for OLE, for process control, and OLE stands for object linking and embedding. And OLE is a proprietary technology developed by Microsoft that allows you to take objects from a document in one application and place them in another. For example, OLE lets you embed an object from an Excel document into a PowerPoint document. And since the object is now linked to both applications, any changes you make to the object from PowerPoint will also be reflected in the Excel document. So, and OLE is part of a larger and more general concept, which is the Component Object Model, or COM, and a distributed version called DCOM. So lots of acronyms for those who like them. The first release of the standard came out in 1996, and soon after its release, the OPC Foundation was formed to maintain the standard. Now, OPC is a client-server technology that was designed to provide a common interface for communications between different products from different vendors. So, for example, before OPC, an HMI manufacturer had to have drivers for all the different protocols that it wanted to support. But now with OPC, it only has to support the OPC standard and then rely on OPC servers to handle the drivers. So this helps users to standardize on a technology that supports many different products and vendors. OPC provides 3 specifications. OPC data access, which is the most common, OPC DA. This specification defines data exchange of data, including values, time, and quality information. You also have the historical data access, and this specification defines query methods and analytics that may be applied to historical timestamp data. And also you have OPC alarms and events, or AE, and this specification defines the exchange of alarm and event type message information, as well as variable states and state management. The main applications for OPC are SCADA-like applications, visualization and control, data collection, and data exchange. In general, OPC provides an easy way to bridge data between the enterprise and the plant floor. Okay, so far I've been talking about the standard now referred to as OPC Classic, which has a few limitations. Like I mentioned at the beginning, it's based on Microsoft COM and DCOM technology, so it's limited to PCs running on Windows operating systems. Also, COM and DCOM can be difficult to configure for remote client-server connections. OPC Classic also doesn't have intrinsic security. It relies on DCOM security. And as I said, DCOM can be difficult to configure, and some users opt to bypass it completely, or simply they just configure it wrong and have problems with it. Also, Microsoft has de-emphasized COM and DCOM in favor of cross-platform capable web services and a service-oriented architecture. It's OPC Classic, it's not scalable, so meaning that it can run on embedded hardware platforms, for example. And lastly, the 3 specifications, DA, HDA, and AE, are not integrated. So you need a separate server if you want to support all 3 specifications. So one server for each specification. So a new standard was released in 2008, with the main goal being to keep all the functionality of OPC Classic while switching from Microsoft COM and DCOM technology to a cross-platform service-oriented architecture. And this new standard was called OPC UA, which stands for Open Connectivity Unified Architecture. And here are some of the benefits. First of all, you have platform independence. OPC UA clients and servers can be developed using Java, .NET, C, C++ to run in different platforms. And they all can communicate with each other if they support the same OPC profile. Also, scalability. The full functionality of OPC UA specification is chunked into profiles that describe subsets of the full feature set. So now OPC UA components can be scaled in functional support, complexity, and footprint. OPC UA can function in traditional computer hardware, cloud-based servers, PLCs, and embedded devices with very limited hardware resources. Also, security. OPC UA uses web services and it's firewall friendly. With the built-in security, messages can be transmitted at 128 or 256-bit encryption levels. Each client and server can be identified through OpenSSL certificates. Applications can require user authentication, and access rights can be set as well. OPC UA unifies the 3 specifications So it unifies data access, historical data, and alarms and events into one address space. So now a single OPC UA server can support all three specifications. It doesn't mean that they all support it, but now the technology was done in a way that now a single server can support all three specifications. And now clients can rely on a single consistent source. So in summary, OPC UA is the latest OPC standard created for industrial applications by the OPC Foundation. It combines the existing standards, DA, AE, and HDA, into a service-oriented architecture, which is platform independent. And if you want to know more about OPC UA, I recommend you start by visiting the OPC Foundation's website at opcfoundation.org. Okay, now let's see how an OPC UA system is configured. So the server has to be configured to access tags from the PLC, and they can be configured as read-only or writable, or you can hide them from any client. Also, the server access and message security settings need to be configured. Now, from the client side, a session has to be created to establish a connection to the server using the server access and message security settings you set on the server. And then a subscription to the available tags can be created. And once this is done, the server will provide tag values to the client. Now, this diagram illustrates an example of a computer-based server architecture. So the server runs OPC UA server software, which needs to support the drivers for the PLCs it needs to connect to. If there's data distributed in various PLCs, the server needs to establish a connection to each of them. Or one PLC can be configured as a data concentrator, like shown here. Now, this diagram illustrates an example of an architecture using a Softing OPC UA server module. So we get rid of the PC server, and this module installs in a ControlLogix chassis and has access to tags via the backplane and or Ethernet IP via a bridge or via its Ethernet ports. So it connects to, and then a client, an OPC UA client, will connect directly to the module via one of its Ethernet ports. To connect to Rockwell's integrated architecture via OPC, Rockwell provides products that support OPC Classic, but not OPC UA at this point. So for OPC UA support, Rockwell has worked with Encompass partners like us to provide OPC UA connectivity to the integrated architecture. So as an Encompass partner, we provide the eATM OPC UA server module. Okay, just a little bit of background about Softing and OPC. We have been a member of the OPC Foundation since the early days, and are part of the OPC Classic and OPC UA specification working group. We currently maintain the OPC UA stack for the OPC Foundation. We're also part of the OPC Technical Advisory Council, the Software Management Group, the Europe Steering Committee, and OPC for Devices. And here are some details about the OPC UA server module. So this module, like I said, fits in the ControlLogix chassis and communicates via the backplane and or by Ethernet IP. It's configured through one of its Ethernet ports using the Softing Appliance Manager software, which is included with the module. Also, you can install in multiple computers, doesn't need a license. And it's fully certified for OPC UA compliance by the OPC Foundation and meets these specifications: the standard UA server profile, version 6.5.47, OPC UA client server communication security, OPC UA client compatibility for scalar tags, UDT component tags, and arrays, and complex type facet ControlLogix UDT support version 6.5.11. Okay, as I mentioned before, the PLC tags are available to the module via the ControlLogix backplane. Also, other controller tags can be accessed via Ethernet IP using one of its Ethernet ports or through an Ethernet IP bridge installed in the same rack. Because the module can access the tags in these ways, there's no need to configure the PLCs to share data amongst each other. So no need to create a publish tags. And OPC UA clients can connect to the server via one of its Ethernet ports. Now this is showing one of the screens to configure the OPC UA server. Once you log on with the username and password, it's very simple to configure the server. So you start on the administration tab, and then you click, on the administration tab, the configuration tab, and you will see the security settings. And under security policies, you can select the type of message encryption, and under message security modes, you can select the type of message security, and under authentication settings, we can enable anonymous access or access to only registered users, and also you can enable or disable the use of certificates. If we use certificates, we need to add client certificates to the list of trusted certificates, and when you go to the client, you need to add the Softing OPC UA server certificate as well. So that's something you need to do manually. Then you have the PLC configuration section, and here we can see the ControlLogix rack. It will be enumerated, and all the CPUs available will be shown. You will also see if you had other PLCs connected via an Ethernet IP bridge or through the Ethernet ports of the OPC UA server, you would see them here as well. So after you select the CPU, you right-click and open the tag list, and you will see not only the controller tags but also program tags. And you can change the column width so you can read the complete tag name. And now you can right-click on individual tags, or you can use Shift-click and select multiple tags and right-click, and you can pick if you want to make them writable or just visible, and also if you leave them, you don't do anything with them, they'll be just invisible. And that's it on the server side. Then on the client side, you have to start by establishing a session between the client and the server, and so you start by creating a connection, and then you have to pick the security options that you enable on the server. So if you chose encryption and what security policies you selected on the server, you have to match them here on the client. Sorry. And you have to enter your username and password, the one you configured on the server. So this is just showing, I'm just showing here a Softing OPC client. It's a demo client, a very basic client that we that we provide free of charge on our website, just so you can test connectivity to servers. So this is just a very generic client. Okay, so after you create a connection to the server, the client will browse and enumerate the available tags. So anything that you made visible on the server will be listed here, and then you can make a subscription. So you can see here I have a subscription. You can create several subscriptions, and each one of them can have a different update rate. So you can add tags to different subscriptions depending on how fast you need the data to be updated. So I can have a subscription pulling data at every 2 seconds, and another one pulling data at 1 second. Depending on how fast I need the data, I will add tags to those subscriptions. So again, in summary, these are the steps to configure data exchange in OPC UA. On the server side, you set up security settings, and then you select the tags you want to make available to clients and give them read or write access. And then on the client side, you establish a connection to the server using the available security options. You create a subscription, and then you add tags to the subscription, and that's it. Then you are ready to read values, and also if you gave them write access, you're able to write to those tags as well. And I'd just like to end with a quick company introduction. I know Scott mentioned a few things already, but just really quick, and then we can open up for some questions. So Softing is a German company and a leading global provider of products for industrial automation and automotive electronics. And for over 35 years, the core business of the Softing Industrial Automation Division has been industrial data communication. We offer hardware and software solutions for process data integration, network diagnostics, and asset management. The product offering includes protocol stacks, network diagnostic tools, OPC servers, OPC middleware, OPC development toolkits, PC interfaces, gateways, protocol converters. We also do training in Germany as well. And if you're already familiar with the tManager and the OPC UA server modules, you probably knew that these products were made by Aldi, and Aldi was acquired by Softing in 2004, and all the Aldi branded products transitioned to the Softing brand. Softing Inc. is a global Encompass product partner. The products available to the Rockwell channel include data exchange modules, communication and protocol modules, and network monitoring and cable test tools. And our company is headquartered in Knoxville, Tennessee. I'm in Newburyport, Massachusetts. We have a small office here with a few applications engineers, and we have Scott, who's in Dallas, Texas, and we have a colleague also as well in there. And our headquarters is in Germany, and we have offices around the world as well. And these, really quickly, are Softing's Encompass products. For moving data, we have the eATM modules, Enterprise Appliance Transaction modules. We also make the computing platform available as the Special Application Module, or SAM, if you want to write and run custom programs. So it's basically a computer that you mount on a ControlLogix. We have both ETAP and ControlNet communication cards that are IEC EX rated, and were designed for the 6180E1X integrated display computers. And in another area of our business, which is cable testing, we have a line of cable certifiers and qualifiers. The certifiers run lab-grade tests required by standards organizations for copper and fiber-based media, and the qualifiers are intended for copper media for Ethernet. And that ends my presentation. So, do you have any questions?
Thanks. I do see we had a couple questions come in during the OPC UA discussion. One being, can OPC UA eliminate produce consume networks?
Yes. You don't need to.
One module for
you don't need to
processors and different chassis.
Okay, sorry, I missed the last part.
Oh yeah, oh, I'm sorry. It was first question was produce consume network. So. Yep.
Yes, you don't need to create produce consume tags. It will browse the tags through the backplane, and also it will go out. If you have an Ethernet IP card on that rack, you will have access to all the PLCs connected through that card as well.
Okay. Our other question was around the one module for multiple processors in different chassis over Ethernet. And as you can drill down from backplane to Ethernet to get data via this card from OPC UA Client. So I think you might have shown that on a slide, but yes, you could basically bridge into the rest of the Ethernet IP network through that module.
16 processors. Yes.
16 processors.
Yeah. You said out 16 processors?
Yeah, 16. Yes. For OPC UA, there's no hard-coded limit actually, but we recommend no more than 16 per module.
But we recommend no more than 16 per module.
So can the OPC UA module, can it be a client as well?
No, only server.
Can it be a server and a client?
No, only server.
Just a
Okay.
server.
So that would answer that first question of can it replace a produce consume network? That would be no, because you need client and server to do produce consume.
Okay, I misunderstood the question.
Okay, I misunderstood the question.
Any questions here in the room? Anyone else on the web could either type in a question on the questions pane, or it's possible I can unmute your telephone line if you want to ask in person. We'll just give everybody a minute to gather their thoughts and questions. Of course, as always, we will post all the information for the session on our blog site, that's the trcnew.com, and of course I'll send out follow-up emails to all of our attendees with that link. So we'll have, I think, the slides as well as some additional softing module information available at that link. All right, we'll make a last call for questions here, and if not, as always, reach out to myself or any of or to your account manager that you're used to working with at Rockwell or the Reynolds Company, and we will be more than happy to help answer. Okay, well, I want to appreciate everybody taking the time to join us, our audience here locally and on the web, and I want to thank Scott and Alex for the presentation today. I think it was pretty informative, as always, and I hope everybody has a safe and happy Thanksgiving next week. Safe travels if you're traveling, and look forward to seeing everybody in December.
Thank you all for your attention. Thank you, Wayne.
Thanks, everyone. Have a good day.
Thank you, Wayne.
All right.
Thanks, everyone. Have a good day.
Yep. Thanks, Scott. Alex.